Good afternoon, guys. Today's topic is interrupts. What we learned in the last class, from last two classes, we discussed about embedded firmware design approaches. What are the two possible firmware design approaches? First one is, can you tell me anybody? What are the firmware design approaches we discussed so far? There are two types of firmware design approaches. First one is the super loop approach. That super loop approach contains an infinite loop. In that, what are the tasks you have to perform is assigned in a sequential manner. Okay, one after one, they uh, executed. Okay, at the end of the last task, it is again goes to the first task. Okay, in this way, it always rotating infinite loop. That's why that is called a super loop approach. Okay, it's having its own advantages and disadvantages already, discussed in that topic. And second technique is the OS based approach. In that OS based approach, again, we organized as a two parts as general purpose OS based system and embedded OS based system. Okay, already okay, embedded system, real time embedded systems always use the real time operating system. Okay, and general purpose processors or general purpose controllers, and those are suitable for not for a specific task. Okay, they are meant for general purpose uses general purpose operating system. Already the super loop based approach doesn't require any OS. Okay, why? Because it is not a hard real time. It is suitable for only specific task. Of course, it is used for specific task, but no need of that operating systems. And there is no need of multitasking. There is of multi-threading. There is no need of task scheduling. Okay, and only small scale applications it is suitable, whereas that voice based system is suitable for hard real time systems and large scale applications. Okay, and those are the two important design approaches we learned so far in the last two classes. Next, embedded firmware development languages. What are the different embedded firmware development languages? Already you best aware of the classification of these languages as low level language and high level language. In low level language, machine level language, and assembly level language. Regarding to high level language, C, C++, Java, Oracle, .NET, PHP. There are several high level languages are there. To convert that high level languages into that low level languages, we need cross compilers. But to convert the assembly language into machine language, we need just assembler. Assembler is the piece of software. Okay, and the schematic of that linker loader, that entire conversion mechanism is shown in the diagram. Okay, please go through that diagram. It is very easy to understand, and it is best aware of you also. Okay. And what is the assembly language, what is the high level language, what is the compiler, what is the assembler, what is the cross compiler. Okay, I explained with I hope it is explained with best example. Okay, and that is what are the languages and what are the languages I speak. Okay, in this conversion, what are the requirements in between you and me? Okay, so that is also general concept. And next one is the interrupts concept. Okay, so today's topic is the concept of interrupts. See here, the concept of interrupt. Can you tell me, everybody, what are the window? Okay, under which topic you see from this window? మీకు కనిపించే విండో ఏంటి? ఇంటరప్ట్ కాన్సెప్ట్ ఏనా? అంటే యాక్చువల్గా నాకు ఇక్కడ 3 విండోస్ ఉన్నాయి. ఓకే, Okay, so next one is the concept of interrupt. Okay, what is meant by interrupt? And the next concept is, and as per syllabus, next concept is ISR concept. And before going to the ISR concept, you have to know what is meant by interrupt. Okay, how those interrupts are organized is the ISR concept, and what are the possible interrupt sources, and what is the interrupt service mechanism. And ISRA, but what is the mechanism they followed, and when come to the multiple interrupts, how they handle those multiple interrupts. Okay, so today's concept is just interrupt. Okay, let's see. Okay, and how much we are able to cover in this unit. Okay, in this class. So here, what is the interrupt? Already you best aware of the interrupt concept. Okay, we already discussed in CAO subject, computer architecture and organization, and embedded system. Sorry, microprocessor and microcontrollers also there exist. This is the crucial concepts of interrupts. What is the interrupt concept? The concept of interrupt. It is very generalized concept. Okay, and while I am taking the class, someone is enter. Okay, someone is entered into my class. Okay, but simply they are asking, may I come in, sir? Okay, that is the one type of interrupt request. In response that interrupt request, and that is the proper way, and that is the just like an handshaking, concept, that is. Okay, and the concept of interrupt is introduced to save the proper functioning. Okay, of course, if for suppose there is no concept of interrupt, there is no possibility of multitasking. Okay, there is no concept of multifunctioning. Okay, and we are always deals with the task within the within minutes, hours, days, weeks. Okay, months, years. Okay, actually మన టైం నెల తీసుకుంటాం మనం, but processor, the microprocessor able to perform all the different operations in the order of microseconds. Okay, microseconds range. So, and in comparison with our humans, microprocessor able to perform any operation within the microseconds. Okay, that's why it is able to perform multiple operations. But how it is capable of handling that multiple operations? Okay, that is able to operate multiple operations at a time, only possible with the concept of interrupts. Okay, and while I am taking the class, if someone enters, sir, may I come in? First of all, the person who asked to enter the class, may I come in, is the request. In response to the request, I am the processor, I am taking the class now. So myself stop the class and answer for that person as, okay, come in. Okay, and may come in, sir, just I receive the request. In response to that request, I send the acknowledgement as, okay, you come in. Okay, and how much time it takes in general? Okay, and in comparison with our regular time, I mean 45 minutes of time, somewhat it is compared to the microprocessor time, it is very huge amount of time, that is. Okay, in that it takes at least 130 seconds time for that interrupt request acceptance and acknowledgement. Okay, and while smoothly going and conducting class is disturbed with one person. Okay, for that person I have to spend my 30 seconds time. Okay, and the person who came for the class, okay, disturb my time, okay, disturb my work and ongoing class. Okay, that person is treated as an interrupt. Okay, but what interrupt do? Okay, what the interrupt do here? Okay, it wastes the it takes some processor time, and me is the processor here. Here me is the processor, and that person is the interrupt. What actions I am performing for that interrupt? Take the request, send the acknowledgement. Okay, and he okay, in this example, just I am take the request and send the acknowledgement. Okay, and it normally smoothly going class is disturbed with that person. That's why that person is treated as an interrupt. Okay, that is the general example of what is meant by interrupt only. Okay, and what actions I am performing. Okay, if the and other than a student, for suppose when HOD sir came to the class. Okay, what actions I do when principal sir came to the class? What actions I do when president sir came to the class? Or NBA committee members came to the class, and NAC committee members came to the class? What actions I do is different for different interrupts. Okay, when student came to the class, just I send acknowledgement in response to that request. Just come into the class. Okay, and that is the action. That is the action I have to do at that time only. Okay, that is only the action. When HOD sir came to the class, it may be quite different. Okay, and what actions I do in response to that interrupt is called interrupt service routine. Interrupt service routine. Okay, and what actions depending upon, and me is the human. That's why I respond spontaneously. But when the same situation came to that machine, and the same situation came to that machine, how it responds? How it responds, we don't know. But that it is a machine. Just that is a machine. That's why what actions performed when one interrupt occur. Okay, when interrupt occur is tabulated in a memory. Okay, and this action performed by, perform this action. Okay, when this type of interrupt came to you. Okay, perform this action when this interrupt came to you. Okay, and different interrupts having different mechanisms. Okay, response mechanisms are different. Okay, and those actions are tabulated in a memory. Okay, that table is called interrupt vector table. Okay, moreover, especially to handle that interrupts, okay, separate instructions are available for the microprocessor or microcontrollers. Okay, if the interrupt is software interrupt, it is quite different. When it is a hardware interrupt and from the external IO devices, that is called the power supply failure. That is also one hardware interrupt. Okay. For such type of interrupts, the mechanism is different. Okay, see here, interrupt concept. Interrupt means event. Okay, interrupt means an event which invites attention of the processor on occurrence of some action at hardware or software interrupt instruction event. Okay, so what is it? There is no need of no need to write like this, but the concept of interrupt is just to compare with and real-time examples. ఓకే, యాక్చువల్గా మీరు క్లాస్ వింటున్నారు. క్లాస్ వినేటప్పుడు యాక్చువల్గా మీ మదరే పిలిచి ఏదో పిలిచి అడుగుతున్నారు. ఓకే, అండ్ యాక్చువల్గా మీరు స్మూత్గా క్లాస్ జరుగుతుంది, మీరు వింటున్నారు అని అనుకుందాం. ఆఫ్ కోర్స్ వినరు అనుకోండి. ఓకే, సో అంటే యాక్చువల్గా మిమ్మల్ని మీ మదర్ డిస్టర్బ్ చేసినట్టే కదా. ఓకే, అంటే దట్ ఈస్ ట్రీటెడ్ యాజ్ వన్ ఇంటరప్ట్. ఓకే, అంటే హియర్ ద ఇంటరప్ట్ ఈస్ ట్రీటెడ్ యాజ్ అన్ ఈవెంట్. అంటే యాక్చువల్గా మనకి రిగార్డింగ్ టు ద ఆపరేటింగ్ సిస్టమ్, వాట్ యాక్షన్స్ ఇట్ ఈస్ పెర్ఫార్మ్డ్ ఈస్ కన్సిడర్డ్ యాజ్ అన్ ఈవెంట్. Okay, that event manager is also there in RTOS here. Okay, action on interrupt. And what action we performed on the interrupt? In response to the interrupt, the routine or program which is running presently, okay, interrupts and interrupt service executes, ISR executes. Okay. What I told you. Okay, and different persons came to the class having different actions I have to perform. Okay, the student action is quite different from HOD. HOD is different from principal. Principal is different from president. Okay, and the different actions have to be performed, and as a human. But when came to that machine, the what action it has to be performed is tabulated in a and what they have to be performed is listed on the memory. Okay, okay, that are listed in the table. Okay, listed in the memory as a table. That table is called interrupt vector table. And that vector notation shows, okay, and that particular address shows what actions they have to be performed. Okay, this is the action on interrupt in response to the interrupt. Okay, in response to the interrupt means when student came, when HOD came to the class. Okay, when principal, when president. Okay, and different priority levels are there. Okay, and based on that person, response is there. Okay, so here also same. In response to the interrupt, the routine or program which is running presently interrupts, which is running presently. Okay, interrupts and interrupt service routine executes. Interrupt service routine. What is the routine? Routine function. What is meant by routine here? Okay. అంటే ఇప్పుడు జనరల్గా మాట్లాడుకునేది ఏంటి? యాక్చువల్గా నేను కరెక్ట్గా 2 o'clock అయింది, 2 o'clock స్టార్ట్ చేశాను అంటే రొటీన్గా స్టార్ట్ అయ్యేదే కదా, కొత్తగా ఏం లేదు కదా. రొటీన్ అంటే ఇట్ ఇస్ ద కామన్ ప్రాక్టీస్ ఇస్ ద రొటీన్. ఓకే, హీర్ ఆల్సో సేమ్. ఓకే, సర్వీస్ రొటీన్ దేనికి? ఇంటరప్ట్స్కి. అంటే ఒక ఇంటరప్ట్ వచ్చినప్పుడు ఓకే అది ఎటువంటి యాక్షన్స్ తీసుకుంటుంది, కామన్గా ఏం తీసుకుంటుందో అంతటిని యాక్చువల్గా వాడు ఇంటరప్ట్ సర్వీస్ రొటీన్ అని చెప్పేస్తున్నాడు వాడు. ISR ఇంటరప్ట్ సర్వీస్ రొటీన్ అంటే యాక్చువల్గా వాడు ఒక నేమ్ అసైన్ చేశాడు అంటే డెఫినెట్లీ హ్యావింగ్ వన్ బ్యూటిఫుల్ మీనింగ్ ఈస్ దేర్. ఓకే, here also interrupt service routine. Okay, that service routine is common for those interrupts. Okay, అంటే కొత్తగా ఏమి ఉండదు, సర్వీస్ రొటీన్ మాత్రం ఇట్ ఈస్ వెరీ కామన్. Okay, what actions they do is the service routine, but what action it performed depending upon the type of the interrupt. Okay, that is also readily available for that machine. Okay, see here ISR is also called as a device driver in case of devices, and called exception or signal or trap handler in case of software interrupts. Sorry. See here, these interrupts are two types. Okay, that is called software interrupt and hardware interrupt. And if you got an just assumption, okay, if I got a health problem due to the malfunctioning of my body parts, okay, or my brain functionality, that is called a just a software interrupt. Okay, either my hand or leg is broken to some external accident. Okay, that is just like an hardware interrupt. Okay, అలా ట్రీట్ చేసుకోవచ్చు కదా, అర్థమయ్యే ఉంటుంది మీకు. ఓకే, హార్డ్వేర్ ఇంటరప్ట్ అండ్ సాఫ్ట్వేర్ ఇంటరప్ట్స్. ఓకే, అంటే ప్రాసెస్లో వచ్చేది జనరల్గా మనకి సాఫ్ట్వేర్ ఇంటరప్ట్స్ వస్తూ ఉంటాయి. బికాస్ ఆఫ్ ది ఎక్స్టర్నల్ ఐఓ డివైసెస్ వీ గాట్ హార్డ్వేర్ ఇంటరప్ట్స్. ఓకే, ఇంటరప్ట్ సర్వీస్ రొటీన్ ISR ఈజ్ ఆల్సో కాల్డ్ యాజ్ ఏ డివైస్ డ్రైవర్. అంటే ఇక్కడ వాడు అలా ట్రీట్ చేస్తున్నాడు అండి, బట్ ఓకే ఇట్స్ క్వైట్ డిఫరెంట్. ISR ఈజ్ ఆల్సో కాల్డ్ యాజ్ ఏ డివైస్ డ్రైవర్ ఇన్ కేస్ ఆఫ్ ది డివైసెస్ అండ్ కాల్డ్ ఎక్సెప్షన్. ఓకే, ఇప్పుడు ఆల్రెడీ మీరు యాక్చువల్గా మీరు సిస్టమ్లో వర్క్ చేసేటప్పుడు కూడా కొన్ని ఎక్సెప్షన్స్ వస్తూ ఉంటాయి. ఆ ఎక్సెప్షన్స్ వచ్చినప్పుడు ఎలా వర్క్ చేయాలో అనేది కూడా అడుగుతూ ఉంటుంది. ఓకే, ఎక్సెప్షన్లో యాడ్ చేయమంటారా? యాడ్ చేసాం అనుకోండి, అంటే సంథింగ్ ఏదో ఫంక్షనాలిటీని ఎక్సెప్షన్లో యాడ్ చేస్తాను అనుకోండి, ఆ ఫంక్షన్ వచ్చినా సరే మనకి ఇన్ఫర్మేషన్ ఇవ్వదు, అది కామన్గా చేసుకుంటూ వెళ్తుంది. దట్ ఈస్ ద ఎక్సెప్షన్ ఆర్ ఏ సిగ్నల్ ఆర్ ట్రాప్ హ్యాండ్లర్. ఓకే, ఎలాగైనా ప్రాబ్లం లేదు అది ఇన్ కేస్ ఆఫ్ ఏ సాఫ్ట్వేర్ ఇంటరప్ట్. ఓకే, సిమిలర్లీ ఫర్ హార్డ్వేర్ ఇంటరప్ట్స్ ఈస్ ఆల్సో దేర్. ఓకే, ఇంటరప్ట్స్ అప్రోచ్ for the port or device functions అంటే వాడు చెప్పేది ఏంటంటే somewhat related to hardware interrupts. Okay, processor execute the program called Okay, processor executes the program called interrupt service routine or signal handler, or trap handler, exception handler, or device driver related to the input output on the port or a device, or related to a device function on an interrupt, and does not wait and look for the input ready or output completion or device status ready or set. Okay, ఏ అవసరం లేదు మనకి. యాక్చువల్గా ఇంటరప్ట్ సర్వీస్ రొటీన్, వాట్ ఈస్ మీన్ బై ఇంటరప్ట్ సర్వీస్ రొటీన్? What are the actions performed by that processor? What are the actions performed by the processor? Okay, what actions performed by the processor? Okay, when interrupt occurs. When interrupt occurs, what actions they performed is called interrupt service routine. Okay, దాన్ని వాడు ఏమంటున్నాడంటే ఇన్ ది టర్మ్స్ ఆఫ్ సాఫ్ట్వేర్ లాంగ్వేజెస్ సిగ్నల్ హ్యాండ్లర్, ట్రాప్ హ్యాండ్లర్, ఆర్ ఎక్సెప్షన్ హ్యాండ్లర్ అన్నీ ఒకటి. ఐఎస్ఆర్ అన్న ఈ మీనింగ్స్ ఇవన్నీ ఒకటి. ఇవన్నీ కూడా మన సిస్టమ్స్లో యూజ్ చేసేవన్నమాట జనరల్గా. సిగ్నల్ హ్యాండ్లర్, అలాగే ట్రాప్ హ్యాండ్లర్, ఆర్ ఎక్సెప్షన్ హ్యాండ్లర్, ఆర్ డివైస్ డ్రైవర్. ఓకే, రిలేటెడ్ టు ఇన్పుట్ అవుట్పుట్, అంటే వాడు ఇన్ రిగార్డింగ్ టు ఐఓ పోర్ట్ చెప్తున్నాడు వాడు. రిలేటెడ్ టు ఇన్పుట్ అండ్ అవుట్పుట్ ఫ్రమ్ ది పోర్ట్ ఆర్ డివైస్, ఆర్ రిలేటెడ్ టు డివైస్ ఫంక్షన్ అపాన్ ఇంటరప్ట్. ఓకే, అంటే ఒక ఇంటరప్ట్ వస్తే ఎలా డీల్ చేస్తుంది అనేది. అండ్ డస్ నాట్ వెయిట్, అంటే ఫర్ సపోజ్ చెప్పే కదా. ఓకే, ఇక్కడ మీరు ఎక్సెప్షన్ అంటే ఏదో ఒక కామన్గా ఒక బెస్ట్ ఎగ్జాంపుల్ ఏంటంటే నోటిఫికేషన్స్. ఓకే, అంటే ఫర్ సపోజ్ ఏమైనా ఒక కొత్త అప్డేట్ వచ్చింది అనుకోండి. కొత్త అప్డేట్ వస్తే మనకు నోటిఫికేషన్ ఇవ్వడం, మనం ఎనేబుల్ చేస్తే మనకి ఎనేబుల్ వస్తుంది. అంటే మెయిన్ మధ్యలో యాక్చువల్గా ఏదో వర్క్ చేసుకుంటున్నాం, మనకు నోటిఫికేషన్ వస్తే జస్ట్ డిస్ప్లే వస్తుంది. ఓకే, అంటే సో అండ్ సో అప్డేట్ ఈజ్ అవైలబుల్. ఓకే, ఇఫ్ మనకి అప్డేట్ చేయమని కొడితే ఎస్ అన్నాం అనుకోండి, అప్డేట్ అవుతుంది. నో అంటే ఆగిపోతుంది, అంతే కదా. ఇన్ కేసు ఫర్ సపోజ్ మనం నోటిఫికేషన్స్ ఎనేబుల్ చేసుకోలేదు అనుకోండి, అఫ్ కోర్స్ అప్డేట్స్ ఉంటాయి, బట్ వీ డిడెంట్ గెట్ ఎనీ నోటిఫికేషన్. ఓకే, ఇన్ కేస్ మనం ఎనేబుల్ చేస్తే ఏమైంది, మనం ఏదో సంథింగ్ సీరియస్గా వర్క్ చేస్తున్నాం, సంథింగ్ అప్డేట్ అవైలబిలిటీ ఉంటే జస్ట్ అప్డేట్ అవైలబుల్ అని చెప్పేసి మధ్యలో వస్తుంది మనకి, అంటే అది మనకి డిస్టర్బెన్స్ కదా, జస్ట్ లైక్ ట్రీటెడ్ యాజ్ అన్ ఇంటరప్ట్. ఓకే, ఫర్ సపోజ్ అది మనకి ఇంపార్టెంట్ అనుకుంటే ఏం చేస్తాం, ఓకే అప్డేట్ అవైలబిలిటీ ఉంది కాబట్టి నేను అప్డేట్ కొడుతున్నాను, సో అప్డేట్ జరుగుతూ ఉంటుంది, అంటే బ్యాక్ ఎండ్లో సంథింగ్ అది ప్రాసెస్ చేసుకుంటుంది. అంటే మరి అది కూడా ప్రాసెసర్ టైంని యూజ్ చేసుకుంటుంది కదా, ప్రాసెసర్ ఫంక్షనాలిటీస్ని, ప్రాసెసర్ పెరిఫెరల్స్ని యూజ్ చేసుకుంటుంది. ఓకే, దట్ కైండ్ ఆఫ్ సిచ్యువేషన్ ఈజ్ హియర్. Okay, that is called exception handling. Okay, device driver, trap handler. Okay, see here, when it is added to that exception, device function on an interrupt and does not wait, అంటే నేను నోటిఫికేషన్ ఎనేబుల్ చేయకపోతే అని చెప్తున్నాడు, అండ్ లుక్ ఫర్ ది ఇంటరప్ట్ రెడీ. ఓకే, అండ్ లుక్ ఫర్ ది ఇంటరప్ట్ రెడీ ఆర్ అవుట్పుట్ కంప్లీషన్ ఆర్ డివైస్ స్టేటస్ రెడీ. ఓకే, దేనికోసం వెయిట్ చేయదు. ఓకే, నెక్స్ట్ హార్డ్వేర్ ఇంటరప్ట్. ఓకే, ఇక్కడ ఒక ఎగ్జాంపుల్తో ఎక్స్ప్లెయిన్ చేశాడు. See here, when it completes the assigned action, or when a timer overflows, or when that okay, it's something software interrupts గురించి చెప్తున్నాడు చూడండి. when it completes the assigned action, అంటే ఏదో సంథింగ్ ఒక యాక్షన్, అంటే సంథింగ్ ఒక వర్క్ చేయమని ఇచ్చాను, అది వర్క్ చేసుకుంటుంది, ఆర్ ఓకే ఒక వర్క్ చేస్తుంది. ఓకే, వర్క్ అయిపోయింది అనుకోండి, అది మనకి ఇంటిమేట్ చేస్తుంది. ఆర్ వెన్ ఇట్ టైమర్ ఓవర్ఫ్లోస్, యాక్చువల్గా నేను హాఫ్ అన్ అవర్లో అవ్వాలన్నాను, యాక్చువల్గా ఇట్ టేక్స్ సంథింగ్ 45 minutes టైం, అంటే యాక్చువల్గా నేను సెట్ చేసిన టైం కంటే ఎక్కువ ఉంది కదా. ఓకే, యాక్చువల్గా అది టైమర్ ఓవర్ఫ్లో. ఓకే, ఆర్ వెన్ ఎ టైమ్ అట్ ద టైమర్ ఈక్వల్స్ అట్ ఏ ప్రజెంట్ టైం అండ్ కంపేర్ ది రిజిస్టర్. యాక్చువల్గా 30 secondsలో మీన్ 30 minutesలో కంప్లీట్ అవ్వాలని చెప్పాను, అంటే ఆల్రెడీ టైం సెట్ చేశాను, బట్ ఇట్ టేక్స్ మోర్ దాన్ దట్ టైం. ఓకే, అప్పుడు కూడా ఏం చేస్తుంది, రెండింటిని కంపేర్ చేసుకుంటుంది, టైం కంటే ఇది ఎక్కువైంది కాబట్టి అప్పుడు కూడా ఒక ఇంటరప్ట్ ఇస్తుంది. ఓకే, యాక్చువల్లీ కొంచెం టైం ఎక్కువ పట్టేట్టు ఉంది. ఓకే, when a time at the timer equals its present time in compared to the register or setting the status flag. Okay, and for example on timer overflow or compare instruction, okay, or capture of time. Okay, or in a click mice in your computer. Okay. Okay. And there is a possibilities of occurrence of the software interrupts, and these are commonly erased. Okay. Similarly, for the hardware interrupts is also there. Okay. Hardware interrupts generates call to an ISR. Okay. Similarly, hardware interrupts are also when interrupt occur, it calls to ISR, interrupt service routine, and what actions they have to perform. See here, when a device or a port is ready, okay, a device or port generates an interrupt, okay, or when it completes the assigned action, or when a timer overflows, when a time at the timer equals to present time in compared to the register or setting status flag. Okay, and all possibilities are not external with an external IO devices. Okay, there is also possibility of getting hardware interrupt here. Because see here, for software interrupts, when software runtime exception, condition. Okay, for example, division by zero. Division by zero is the one of the commonly available software interrupt, or overflow or illegal opcode detected. Okay, actually ADD is the common instruction. If we assign instead of ADD uh, something ADB, and in case by mistake if we type like that, that is also given under such type of uh, interrupts, software interrupts. Okay, the processor hardware generates an interrupt called trap, which calls on ISR. Okay, the processor hardware generates an interrupt. Okay, and the trap is it a hardware interrupt or software interrupt? In 8085, 5 hardware interrupts are there. Okay, in that, trap is the highest priority non-maskable interrupt. Okay, and here they consider the example of that a trap and RST 4.5. Okay, RST 4.5 is the one hardware interrupt. Okay, when software runtime exception condition defined in a program, okay, then software instruction is executed called software interrupt or exception or signal, which calls an again ISR. And in both cases, in both hardware interrupt and software interrupt, they calls upon ISR and what actions they have to do on the occurrence of that interrupt. See here, example, when a software runtime exception condition see here, example here is uh, see here, software can execute the software instruction. Software instruction is the SWI, or interrupt N. INT is the common acronym used for that interrupt notation. INT 0, INT 1, INT 2, INT 3. That is the standard notation used by any processor controller here. Okay. Interrupt N, INT N, to signal execution of ISR, interrupt service routine. Okay. The N is as per the handler address. Okay. Here int 0. 0 is the address of that. I told you that interrupt vector table and what actions they have to perform in response to the occurrence of the interrupt. Okay, best example is for 8085 we use uh, int 3 int 03h. Int 03h is the uh, interrupt used to uh, intimate that is the end of the program. Okay. And when that int03 instruction is executed, it never execute what are the instructions given after that int3. Okay, similarly for int21h, Okay, into 21H, that is also the same kind in the 8086 processor. Okay, or similarly halt HLT. Okay, like EXIT, exit. Okay, see here, software can execute the software instruction or interrupt n to a signal execution of ISR. The n is as per the handler address. Okay. Here signal interrupt, and the signal differs from the function in the sense of execution of a signal handler can mask until mask is reset. Okay. The handler will not execute on interrupt. Okay. అంటే యాక్చువల్గా ఇక్కడ టూ టైప్స్ ఉన్నాయండి. అంటే యాక్చువల్గా ఇప్పుడు ఇంటరప్ట్ని ఎగ్జిక్యూట్ చేయాలా వద్దా? ఓకే. And again there are several priorities. Priority levels are also there. Okay. In this 8086 and 8051 microcontroller, two conditional flags are there. Enable interrupt and disable interrupt are also there. Interrupt flag is there for 8086 microprocessor. What are the 9 flags? Sign 0, carry, parity, auxiliary carry, overflow. Okay. And what about remaining 3 flags? Directional flag. Okay. Directional flag. Another one is trap flag, step by step mode execution. Next, interrupt flag, IF. Okay, what is the flag? What is the interrupt flag indicates? Okay, for suppose I am not enable that interrupt flag, I am not enable that interrupt flag. Did the processor able to take any interrupts from any interrupts, any external interrupts? No. Okay, even they didn't know is that interrupt occur or not. Okay, if I am enable that interrupt flag, okay, they are ready to, and if they frequently checked is it interrupt occurs or not, is it interrupt occurs or not. Okay, and just like an while of one, and just that is the infinite loop, and while doing some task, while performing some task, it frequently check that port, is it the interrupt occur, and the person told me that another person uh, came to work with them. Okay, just like that situation here, when we enable that interrupt flag, it frequently checked for is it the interrupt occurred or not. Okay, it's frequently checked just like an while of one loop. Okay, that is the situation here also. Okay, the signal differs from the function of the sense that execution of a signal handler can mask until the mask is reset. Okay, just like an interrupt flag enabled or not. The function on the other hand always executes on the call after call instruction. Okay, and a conditional and unconditional two types are there. Okay. Call instruction is intentionally calling subroutine function. See here, this is the service mechanism in pictorial form. Okay, interrupt driven actions. Okay, see here, this is the normally executed program. This is the normally executed program like this. Okay, if any interrupt occurs during this program execution, if any interrupt, okay, if any interrupt occurs during the program execution, okay, which is having highest priority, then in response to that interrupt, it has to go for some actions regarding to that interrupt as interrupt service routine ISR. Okay, again that ISR program is executed, and that is the what actions they have to do is executed, and again goes to the main program, and continue that program. For suppose if it gets again any interrupt, again goes to the ISR, execute the same and came back, okay, and resume with, okay, the that current program, okay. For suppose while executing that ISR, if it gets another interrupt again, okay, which is having a highest priority than this currently executed program, again go for ISR, execute that program and go to the ISR previous program and complete that program, again goes to main program, okay. And this type of situation is called nested interrupts. This is called nested interrupt concept, okay. For suppose if I am not enable that interrupt flag here, not enable that interrupt flag here, okay, even interrupt occurs, it doesn't take that interrupt, okay, and never save for that interrupts, okay. It just it executes the what are the program is currently executing, okay, and it is dedicated to only single functionality only, and with there is no concept of interrupt, it is dedicated to single functionality, okay. This is called interrupt driven actions. For suppose here one more concept is there, while executing one interrupt is there, while executing that first interrupt second interrupt is occurs, if it is highest, if it is having highest priority, then that go for, then the program control goes for that second interrupt while executing the second program second interrupt, okay. If it gets any highest priority interrupt, again go for third one, after completing the third one goes to second, and after executing the second interrupt, again go for that first interrupt, okay. After completing that first interrupt, again go for the main program, but because of this process that currently executing program takes a lot of time, okay, for that completion, okay. And this type of problems are arised when there is no concept of RTOS, I mean OS concept, operating system, okay. If the operating system is available, then that operating system assigns, okay, specific time for each task, okay. That is called a task scheduling, okay, task scheduling, okay. And because of that multiple interrupts, there is a problem called uh, deadlock condition, that is also occur, okay. That is a separate concept, we'll discuss later in the uh, functionalities of RTOS, okay. Understand what I told you in the interrupt driven actions. See here, how does call to ISR differ from function call? Okay. The call function is somewhat different from the ISR call. See here, on a function call, the instructions are executed from a new address. On a function call, the instructions are executed from new address. Okay, what is the different? Executes like in as a function in the C or any method of Java. ISR also, the instructions are executed from the new address like as a function in the C or any method of Java. Okay. And it is the and again, I mean, these are all unconditional, and okay, some additional unconditional calls and conditional calls are there. Unconditional calls and conditional calls are there, just like an interrupts they are, okay. They executed like an interrupts, but that call program having the specific address where it has to be executed, okay. And simply the subroutine functions are executed with that call functions, okay. And they are commonly used in that C and Java languages. Okay, these are the features of the routine call and ISR call function. ISR calls. Okay, the function call is after executing the present instruction in any program and is a planned diversion from the present instruction in the sequence of instruction to other sequence of instructions, and just like a main program to subprogram. Okay, the sequence of instructions executed till the return from that. Okay, and when we use the instruction, when we use the instruction called call, okay, that call having that 16-bit address or 32-bit address depending upon the type of microprocessor or microcontroller. When that call something xxxx, okay, occurred during that program execution, it go for the address called xxxs, where whatever the program written on that subroutine, that program is executed, and never get, okay, never go back to that main program until it faces the instruction called ret. Okay, and a call function definitely uses ret instruction return. Okay, call and return especially used for the subroutine functions. Okay, that is the difference here. Okay, the function call is after executing the present instruction in any program, and it is planned diversion from the present instruction, and where that call something XX is executed in sequence of instructions to another sequence of instructions. This sequence of instructions is executed till the return from that. Okay, and when it faces the instruction called return. Okay, these are two instructions. An ISR call is after executing the present instruction in any program and is interrupt related diversion from the current sequence of instructions to another sequence of instructions. This sequence of instructions executed till the return from that or till another interrupt having higher priority. Okay, what I told you just in the um, uh, before slide. Okay, the same concept given here as a theoretical concept. Okay, see here nesting function calls. Okay, okay, nested interrupts or here nesting function calls, and intentionally I am calling the subroutine function. Okay, intentionally I am calling the subroutine function. Okay, that is the nesting function calls, and that call function, that subroutine function internally having again some call functions, again that call function internally having again another call function, that is the nested call function calls. Okay, nesting the function calls when a function 1 calls another function 2, and the call and function 2 call another function called function 3. On return of function 3, return is go to that function 2, and return from function 2 goes to that function 1. Okay, and just like, okay, this is the main program, this is the function call execute on program. While executing the subroutine, it again calls second function call, again it execute third function call, again it execute for suppose fourth function call. When it completes and return to 3, third function call again goes to here again while executing, and it faces return call 2, it goes to that second function, again goes to 1, again goes to main function. Okay, this is called, okay, this is called nested function calls and return calls. Okay, here call function 1, here call function 2, here call function 3, here call function 4, here return 3. Okay, here return function 2, here return function 1, here return to main program. Okay, understand? Okay, this is called nesting. Okay, this is the main program execution. These are called nested calls and subroutines. Okay, when the similar concept with respect to interrupts, these are called nested interrupts. Okay, and while executing that nested interrupts, there is no return function or call functions are available. Okay, see here, and this is called ISR. This is called ISR1, ISR2. This is ISR3, ISR4. If it is different, the ISR calls in case of multiple interrupt occurrences can be nested or can be as per priority of interrupts. Already I told you the uh, priority levels. Okay. Okay. See here, using the interrupts and ISRs for each device function. And for example, read and write. And what read and write examples తీసి చెప్తున్నాడు వీడు. So they're according to the software interrupts అన్నమాట. Okay. So సరిపోతుంది for today's class. Okay. This is the concept called interrupts. Okay. So next interrupt driven IOs చూద్దాం next class లో. Interrupt driven IOs. Okay. For today's class is enough. So I will continue in the next class. Okay, thank you.